All right, today we're going to do assembly basics. And essentially what you're going to start with first is to create an assembly. Now, to create an assembly, just hit New, Assembly, and hit OK. Now, initially a screen will pop up with parts essentially that you want to start with. I'm going to hit Cancel right now, but usually you would start with your like base piece, like what you're starting with. And I'll show you what that eventually does, but we're going to hit cancel first. Now, on the left side here is just beginning your assembly. And as you can see, there's a few different options, thumbnail preview, whatever. The options are usually the same and usually stay the same. So there is the most important one is fix/float component on insert. And usually you want to do only fix the first component. And so what fixing the first component does is basically makes it to where you're not able to drag around in the program. And to kind of exemplify that, I'm going to click Browse, um, and you just go to the folder where your files are located. Now I'm making this kind of like rotating wheel spinning thing. It'll make sense once it all gets put together. But I'm going to create a base, and the base is already made, and it appears on your cursor, and you just drag it down wherever. On the first piece, it doesn't really matter. Even if I put it over in this corner and I click it down, it'll like drag it back to the center. It'll make the camera um, center it. As you can see, on the bottom right, we're fully defined, and it says the selected component is fixed. It cannot be moved whenever you click on it and try to move it around. And that's okay. And that's what we want, actually. So we have our initial piece in here, and there's an assembly tab. You can insert components, and the few different options is you can insert a new part. And if you click one of the new part, essentially you just create a new part in the assembly. Just hit new part and yeah, so you can edit stuff, whatever. So we're just gonna delete that. Don't need it anymore, and our base is still fixed. So to insert components, you just click the insert component, and there's a like a thrust bearing here. And these are downloaded from McMaster-Carr. It's a very common site. A lot of manufacturing companies use McMaster-Carr for their hardware. Um, and if you look down in the bottom left here, there's rotation things. So say this one of the pieces was rotated, you can just simply rotate it to whatever orientation you needed at that time. So essentially you just click it down, and like I said, the base doesn't move, but this one does. Now, really, the next step here is to mate things. If you're not going to mate things, you just insert the rest of your components. So insert components. Next is this centerpiece right here. And I'm just going to place it right there. You can rotate around it and stuff like that. Usually, you might use linear component like patterns like this, like smart fasteners. Um, Move component, usually you don't use anything from here to the right. In perhaps larger companies, you might use bill of materials, where it'll have a pop up to the side and you'll insert everything and it'll do all the math and stuff like that. But for now, um, we are going to mate these pieces. And so in the mate part, there's a lot of different types. Coincident, parallel, perpendicular, tangent, concentric, lock. Um, and there's more advanced ones. There's more mechanical and um, analysis, which I've never used, but mechanical does get used sometime. Um, so for right now, you have all your parts, and you kind of have to think of how am I going to put this together. So I'll X out of this real quick. Usually, you'd want to put this bearing in first, and then this thing, if you look on the bottom, it has a slot for the bearing. You'd put it in there. So you wouldn't obviously go like this and then put the bearing in. That wouldn't make any sense. So when you're mating things, do it step by step. So in this case, I want these two holes to be centered, essentially. So what I'm going to do is I'm going to zoom in. I'm going to go in pretty close and select this, okay? And then I'm going to select this other circle. And concentric makes two centers. It just makes them centered. So the middle of the circles are in the same place. And we can hit check there, but notice how it's not seated properly. This can still move vertically. To change that, we want to have a mate where this face right there is flush with this face. And usually, the computer will automatically be able to tell what you're trying to do. And if I just hit the check mark and the X, it's all mated. And so you can drag your mouse, and that's because if you look really closely, it's actually rotating. And so bearings actually do that. This bearing specifically doesn't have the mates inside where it rotates correctly, so just the entire thing rotates, and that's perfectly fine for our use case. So now we need to do the same thing with this. So we're going to hit mate. We're going to make sure this holes or the centers of the circles are aligned. We hit check. And so now, like I said, it's kind of going up and down, and we don't want that. So to seat this properly, select this, select that. It will become coincident, which means two of they're touching, essentially. Hit check. And there is a little space. This is not the proper way to use this bearing, I don't think. So it's fine the way it is, though. Now this piece rotates. It is kind of like buggy. If you like keep rotating it, it kind of like flips back and forth, and that's okay though. So right now we have this. We're gonna insert a few more components. There is another bearing that I used, and notice how it's not aligned quite right. You can um, use this bearing, set it down, and just select the surfaces you want, um, which I will do. So mate, and when you're putting in a bearing, you usually want the outside race of the bearing to touch this surface. So what I'm going to do, select the outside part of the bearing, select that, and notice how it rotated in. It rotated correctly to this surface, the correct orientation. Usually your parts will do that, and it's not a big deal. Next, what we're going to do is, let's say this bearing, obviously it's moving in and out, which you don't want, is centered exactly in the middle. How do you do that? Well, these happen to be the same width. So notice how it's 0.31. And if we hit evaluate and measure, in assemblies, this might be your most useful tool is the measure tool. You click that, and it's 0.31. I did design this to be properly the right width. So in theory, you could go back to assembly, hit mate. You could select the outermost surface, which is here, and this surface, and I want them to be well, not parallel, coincident. So what this does is it just makes the planes touch, if that makes sense. So this surface would be flat with this surface. That's what that does. And so this one is also rotating, but once again, that's what bearings do, so it's fine. But notice it can't go in or out. This thing can rotate, but this bearing can't go in or out of the piece. Now I'm gonna do the same thing, but this time I'm gonna do it slightly differently. I'm gonna select the ball bearing, and I'm gonna hit mate. But this time I want it to be in the center of this piece, even if this piece changes widths. Now, this is kind of thinking pretty far ahead, and it's only a few seconds. But if we go to advanced, and we choose the width mate. On width selections, well, we want this side and this side to be equal to this side and this side. So notice how it flips to the middle of the piece. Now, granted, this piece, this mate type, is kind of difficult to understand at first, but basically, it makes the distances between the two blues and the two pinks the same. Um, and we can just hit check on that, and it's always going to be with this piece. Now, we need to go back to standard, hit concentric, and we need to make that circle concentric with this circle. It snaps it in place, we hit check, and now this bearing only rotates, which is what we want. So, now that we have a bearing down there, two bearings up here, we need the shaft and the wheel that goes on this. So, to insert components, shaft and wheel, and you can select more than one at the same time. Just hit open, click that, and done. Now, these obviously can be moved, so let's attach them to this. Once again, I'm going to do this in a little bit separate step. I'm going to mate this wheel to this shaft. So I'm going to mate, and I want this inner circle to go on this shaft, right? So now I can move this, but I can move the wheel back and forth. I want it to be in the middle. So how do you get it in the middle? Go back to advanced, width, and our two blues, and our two pinks. Okay, select that. So now the wheel just moves around like that. Technically, it can rotate, but it's only going to rotate once we get this piece locked. So, once again, we want it to be in the center. So we're going to hit mate, advanced, width. And the constraint, it can be, usually you want it centered, but sometimes it's like free, dimension, percent. But like percent you would use if you want it like 3/4 the way to one side, which we can mess with in a second. With the width selection, I want this to be the two blues and this to be the two pinks. It'll snap it right in place. So now move up and down, but we need this shaft centered on this. To do that, we just hit standard, that shaft onto that, and there you go. Now, the shaft does not move. This can rotate, which is exactly what we want. Now let's say I didn't want this actually in the center. Instead, I wanted it a little bit to the side. That's okay. To go back and look at the mates, you're going to go on the left side under mates, open up the drop down, and find which one. Remember, it was width, and it selects the faces. If you select the mate, it selects the faces. We're going to hit width 2. We're going to edit the feature, and we're going to do percent. So right now it's 50%, obviously, and it's telling you that it's from this side. So if I just go down a little bit, hold on. If I go down to say 25%, it's going to move it to 25% the distance. And that looks about right. If you divided this piece into quarters, that would be about the quarter mark. We can just hit check, and it works just the same. This piece also rotates, and there can be multiple degrees of freedom in your assembly if you'd like. Oftentimes, you want to define everything and make sure everything is quote unquote locked down. But in this case, it is a movable piece, and there are things that do rotate. So, that is the basics of assembly making. Sometimes in larger assemblies, say you messed up this bearing, like you don't want this bearing to be there anymore, or you want to move it to somewhere else. Sometimes you will have to delete um, the mates. So if I just deleted that, now this piece moves. Obviously, I hit Control Z because I want it to be there. Now, many times, if you hit mate, you can select this, select two surfaces, and you can lock them. You can lock it exactly where it was at. Now, if you hit check mark, it's fully defined. And sometimes this does cause issues. So use it very carefully when you're on larger assemblies, because sometimes you'll want to try to move something a little bit. This will be fixed, and it'll make a whole lot of things more complicated.